Right, so today we're going to dive into big data and Hadoop. You sent in a ton of material, so I can tell this is something you really want to get a grip on. These massive data sets.
Yeah, and you came to the right place. It's not just about the size.
Right.
Although it is pretty mind-boggling when you think about it.
Right.
Just imagine every credit card swipe, every Facebook post, every tweet someone makes, even CCTV footage, all of that data piling up every second. That's the scale we're talking about here.
It's almost like trying to drink from a fire hose.
Right.
It's no wonder traditional systems kind of start to choke.
Exactly. And it's not just the sheer volume, it's the speed, the velocity at which it comes in, plus all the different types, the variety. It's not nice, neat rows and columns anymore. It's messy, unstructured data from everywhere.
Okay, so we've got mountains of this data. It's constantly changing, and it's about as organized as my junk drawer.
Yeah. What makes it so difficult to manage? Why can't we just use bigger spreadsheets?
Well, because you're talking about a completely different way of storing and processing information. I mean, those spreadsheets, they live on your computer, right?
Right.
Which has limited storage and processing power. Big data just blows past those limitations.
Okay, so what's the solution? How do we even begin to tame this big data beast?
That's where these distributed file systems come in, or DFS. So picture a network of data warehouses, all connected and sharing the burden that's DFS in a nutshell.
Okay, so instead of one giant server struggling, we're spreading the data across a whole bunch of machines. You got it. And this is what unlocks some really cool benefits. The one that I think drew you in is this idea of transparent local access. It's kind of mind-blowing, but you can work with these huge data sets as if they were on your own computer.
Wait, really? No more waiting for files to download from a remote server.
That's right. The DFS takes care of all that behind the scenes, so you can focus on analyzing the data, not where it's physically located. And that leads us to the next advantage: location independence.
Okay, you're going to have to explain that one. What makes the location suddenly irrelevant?
Well, think about how you normally work with files. They're in a specific folder on a specific drive. With a DFS, that physical location is practically meaningless.
So the data just exists out there in the cloud.
In a way, yeah. The system keeps track of all the pieces, but you don't have to. It's like having a personal assistant who always gets you the right file without you needing to know which filing cabinet it's in.
Okay, that's impressive. All right, we've got transparent access, location independence. What other tricks do these distributed file systems have up their sleeves?
Two more big ones. Both are really important in the world of big data. First, you've got massive scaling. As your data grows, and believe me, you can just add more machines to your DFS. It's like having an expandable data center.
So no more frantic calls to IT when you're running low on storage space.
Exactly.
That alone is amazing.
And lastly, and this is a big one, when you're dealing with critical data, there's fault tolerance. So if one machine in your DFS decides to take a break,
The whole system crashes.
no, it just keeps on running. That's the beauty of having all those copies spread across multiple machines.
So even if one part fails, the data is safe.
Exactly.
Okay, that's reassuring. So we've established these distributed file systems. They're the heavy lifters of big data. But how did we go from spreadsheets to this elegant, interconnected system? Was it a sudden breakthrough or more of a journey?
Well, every good story needs an origin, and this one starts with a little company called Google.
Google, the masters of data.
Oh.
What did they bring to the table?
Well, back when most people couldn't even fathom a petabyte Google, they went ahead and created the Google File System, or GFS for short. It was how they handled the insane amount of data created by search and indexing.
I can only imagine what that system looked like, being able to handle that much data back then.
It was groundbreaking. But the important thing is Google didn't keep GFS locked away. It actually inspired a wave of open source projects that brought similar capabilities to everyone. And one name stands out: Hadoop.
Hadoop. We can't talk about big data without mentioning Hadoop, right?
Right.
But how did it go from a niche project to the go-to solution for dealing with these huge data sets?
It all began with a web crawler named Apache Nutch. It was designed to index the entire internet. Talk about a data-heavy task.
Yeah.
They needed a way to manage all of that information, and, inspired by GFS, they created Hadoop's distributed file system, HDFS.
So Hadoop wasn't some random project. It came from a need to manage the wild, untamed data of the early internet.
Exactly. It was a solution born out of necessity. Actually, there's a quote from one of the articles you sent over. It says, HDFS was born from this and is designed to replace hardware storage solutions with a better, more efficient method of virtual filing system.
It really shows the power of software, doesn't it?
Right.
We're not relying on bigger, faster hardware. We're using clever software and these distributed systems to tackle these huge data sets.
Exactly. And that clever software, Hadoop, it's more than just HDFS. It's actually a set of modules, each with its own job in managing the big data beast.
Okay, well, let's meet these modules. Break it down for me. What makes Hadoop tick?
All right, so let's meet the Hadoop team. First up, we've got the cornerstone of it all, HDFS, the Hadoop Distributed File System.
Okay.
If Hadoop is a house, this is the foundation.
Got it.
And it's designed to handle those 5 V's we talked about earlier: the volume, the velocity, the variety of the data, the veracity, making sure it's trustworthy,
Right.
and then ultimately delivering that value.
Yeah.
That makes it worthwhile.
So it's not just about storing the data. It's about storing it in a way that's fast and flexible and reliable and useful.
Exactly.
Got it.
Next, we have Yarn,
Okay.
yet another resource negotiator.
Edgy.
Yeah, don't let the name fool you. This one is important. Think of it like the conductor of an orchestra.
Okay.
That's Yarn. It manages all the resources in your Hadoop cluster and makes sure everything runs smoothly.
Resources like processing power, memory, that sort of thing.
Exactly. Yarn decides which task goes where, assigns them to the right nodes, and it keeps the whole operation running efficiently, even when you're dealing with insane amounts of data.
So it's like the maestro making sure all the musicians are in sync playing their parts.
Precisely.
Okay.
Now imagine taking a massive data set, right? And then you split it up into these smaller, more manageable chunks so they can be analyzed at the same time. That's MapReduce Hadoop's processing powerhouse.
Okay.
It's a divide and conquer strategy perfect for big data.
So how does that work in practice?
Okay, so think of it like a huge jigsaw puzzle, way too big to solve on your own.
Right.
So you split it up into sections and you give each section to a different person.
Okay.
That's the map phase. Each node gets a piece of the data and analyzes it on its own, looking for specific patterns or insights. Then we have the reduce phase, where all the individual solutions are combined to see the big picture.
So each node solves its own little part of the puzzle, and then MapReduce puts it all together to get the full image.
Exactly. It's like a team of detectives, each one investigating a different lead.
Right.
And then they all share their findings to solve the case.
Like it.
And finally, we have Hadoop Common, which is like the toolbox. It has all the libraries and utilities that the other modules need.
So it's the glue that holds the Hadoop ecosystem together.
Exactly.
Okay, that makes sense. But enough with the theory. How is this actually used in the real world? Give me the good stuff, the case studies.
Oh, there are some really cool ones. Let's start with UPS, the logistics company.
Yeah.
They had this challenge. Actually, a lot of businesses have this challenge, and that's optimizing delivery routes for efficiency.
Yeah, anyone who's ever followed their GPS down a wrong turn can relate to that one.
Exactly. But how does big data help with that?
Right.
Well, UPS had been gathering data from their delivery trucks for years. Speed, location, even things like braking data.
Wow.
They realized that if they combined all that with real-time traffic information and other factors, it was incredibly valuable.
Right.
It was a gold mine.
Okay, so they turned to Hadoop to make sense of it all.
Exactly, they did. And they created this system called ORION,
Okay.
which stands for On-Road Integrated Optimization and Navigation. And thanks to Hadoop's ability to process all that data, ORION saves UPS 100 million miles driven every year.
100 million miles. That's like driving to the sun and back twice.
It's a lot.
Yeah, that's incredible. And I can only imagine the fuel savings alone, never mind the environmental impact.
It's huge. And it's not just logistics. Let's look at retail. Tata Companies. They have this subsidiary called Tata IQ, which focuses entirely on big data and analytics.
Tata, like the global conglomerate?
That's the one.
Okay.
So they realized that with all their different businesses, they had this gold mine of customer data.
Right.
Just sitting there. They wanted to know things like buying patterns, product preferences, really understand the customer journey.
So like hyper-personalized marketing, laser-focused product development.
Exactly. And they had these aha moments where they discovered things like sound products, headphones, speakers had a really high chance of being purchased with mobile phones.
Interesting.
So their retail chain, Chroma, they redesigned their stores, put those sound products closer to the phones.
Oh, that's a subtle change, but I bet it had a big impact.
Huge. Sales jumped just from that one insight. But it goes beyond just sales. Tata IQ helped different Tata companies tailor their marketing, make the customer experience better, and just make smarter business decisions overall.
It's amazing what you can do when you go from being overwhelmed by data to actually using it to your advantage.
It is.
But it makes you think, with great data comes great responsibility, right?
Oh, absolutely. And that's where data integrity comes in, the unsung hero of the big data world.
Because you can't assume all this data is accurate and reliable.
Exactly.
So how does Hadoop make sure we're not making decisions with bad information?
Well, that's one of the things Hadoop does really well. It has these built-in mechanisms that make sure your data's integrity is sound every step of the way. Almost like having this team of data quality control experts working behind the scenes.
Okay, I like it. Data guardians. How do they work their magic? What's their secret weapon? Data guardians, secret weapons. You got to give me more details here.
Yeah.
How do they keep all the data in check?
Well, one of their key tools is the checksum. It's like a unique fingerprint for every piece of data that gets stored in HDFS, almost like a tamper-proof seal.
Okay.
So every time the data is moved or even accessed, Hadoop checks the fingerprint.
So if even one tiny bit of data is wrong, Hadoop knows.
Exactly. It's very sensitive to change. And the best part is Hadoop doesn't just detect those errors, it can fix them too.
Hold on. Data repair. Are we talking sci-fi here?
Not quite sci-fi, but some pretty smart engineering. Remember how we talked about data replication across the DFS?
Yeah.
If one of those copies gets messed up, Hadoop just swaps in a good copy from another machine. It's constantly monitoring and comparing those fingerprints to make sure you're working with the best data possible.
That's impressive. It's like a self-healing database, taking care of itself.
Pretty much.
Okay.
Yeah.
But let's shift gears a bit. I know our listeners are probably eager to try this out.
Right.
And honestly, so am I. Is this all complex code, or can someone like me actually wrap their head around Hadoop?
You don't have to be a code wizard to use Hadoop. HDFS actually has its own set of commands that are pretty user-friendly.
Really? So what can you do? Give us a sneak peek at these commands.
Well, some of the basic ones are IPUT, which uploads your files, then AGET to retrieve them. ELS lets you see what's in a directory. Aom and Haradir creates a new directory, and Aom Haradir will remove an empty one.
So even if you're not a programmer, knowing these commands lets you navigate the world of Hadoop.
Exactly.
That's great. So we've talked a lot about what Hadoop is and how it works, but I want to bring it back to that essential question.
Right.
What can you do with it?
Right, so we saw how UPS used Hadoop to change the game for their delivery routes, saving all that fuel and making a positive environmental impact.
Right.
And then there's Tata, using data to better understand their customers and make really smart business decisions.
Exactly. Both of those companies, they used Hadoop to find those hidden patterns, to optimize how they do things, to get a real advantage over their competition. So my question to you, the listener, is this. What possibilities does this open up for you?
That's right. What insights are hiding in the data you see every day?
What problems could you solve? What opportunities could you grab if you could unlock the power of big data?
It's really a call to explore, to dig into the data all around us.
And who knows what incredible things you might find.
Exactly.
This deep dive was just the tip of the iceberg when it comes to big data and Hadoop, but hopefully it's made you curious. So keep asking questions, never stop learning, and most importantly, keep on diving deep.